So now we've got the beginnings of some simple programs. We can write straight line programs, store them away in a file and run them in the scheme, a Python interpreter whenever we want them. But basically they're still pretty simple things. They're straight line because I'm just following a sequence of instructions in order. So I'm still essentially doing things like a calculator. When we talked about the machine, we said one of the other things we wanted to be able to do was to make decisions, to do a test. And on the basis of that test, jump to some other part in the sequence of instructions. Do one thing if the test is true, do a different thing if the test is false. So we need branching programs, things that make decisions or branch based on that test. And the simplest branching statement in Python is a conditional. Conditional is the obvious statement because it basically says if we have some set of code, when we get to the conditional, we start by executing a test, which is a Boolean. And based on that Boolean, that expression that either evaluates to true or false, if the value of that test is true, then there's a block of code called the true block that we execute based on that. If the value of the Boolean is false, then we may decide to do a different set of things. So there's a second block of code called the false block, the block of code we're going to do if the test is false. Now, that second block is actually optional. We don't have to have it. We always need to have the true one. What do we do if the case is true? But if we decide if the thing is false, we don't need to do anything. We can simply skip that second portion of it. Either way, after we've gotten through that conditional set of expressions, we can pick back up with the next sequence of instructions in the code, just as we would sequentially before. So this is a way of us now making decisions, and based on the decision doing one thing in one case and something different in a different case. How do we get Python to recognize that? Well, let's look at a simple example. And here's some code, which I also have over here in a Python file. I've got an instruction right here, this first one, that says, shown right there, that says I'm going to, as I did before, ask for some input, and I'm going to create an integer. And then I'm going to do a set of instructions. And those set of instructions are going to first do a Boolean test. So there's that Boolean. And this is the remainder. It says if the remainder of x divided by 2 is 0. That says if I divide that x by 2, there is no remainder, so it says it's even. In that case, I'm going to print something out. And notice the indentation here. That's important. That indentation tells me that this is a sequence of instructions to do based on what happens if the test is true. And that could be arbitrarily many instructions there. I have similarly next to that if, and that if is a special form there that says do the evaluation of this expression, and it ends in a colon. Below it, I've got another keyword, else, followed by a colon. And this tells me where to find the block of code to execute if the test is false. And again, notice the indentation here. So what this says is I'm going to execute that instruction. I'm then going to execute this test. And if that test is true, then I will execute that set of instructions. On the other hand, if that test is false, I will look for, or rather Python will look for the else and execute that set of instructions. In either case, notice that there's no indentation here, so this is now the next instruction after this entire conditional right there. So let's go over to Python and see what happens here. So there is my file. I'm going to load that in. It's now executing the first instruction, so it's waiting. It says, give me some input. I need to give it an integer, so I don't know, let's give it the value 6. And it prints out a blank line, which came from that first print statement, and then the word even, or the string even, and then notice it prints out the done with conditional. Let's go back over here and load that up again. So again, it's waiting for an input. I give it a 5. And now in this case says since the test is false, it jumps to the false block of code after the else, prints out a blank line, prints out string odd, and then in either case, as it said, that last expression is always the next expression done. It prints out the done with conditional. So you now see how I can make choices, and I can branch. I can do different things based on a particular value of a test. And we see the format here. In this case, there's an if, some Boolean test, followed by a colon, followed by a sequence of instructions that are indented. By the way, Python, or the idle system, will do that automatically for us, and then followed by an else. Okay, let's make some observations here. We've already done that, but just to remind you, that expression x remainder 2, is that equal to 0 evaluates to true when, in fact, x divided by 2 has no remainder. As we said before, we're using the double quote for comparison, because we use the double quote, we're using the double equal sign for comparison, because a single equal sign is reserved for assigning a name to a value. We've already talked about the indentation, which is important. It denotes a block of instructions. And that indentation gives us a nice visual structure that helps reflect the semantic structure of the program. We can look at the code and easily identify the different blocks of code associated with the true and the false block. Now, some variations we can do here. We can have nested conditionals. So if we look at this, we've got an if, we've got a block of code, but that block of code is itself an if, which has another indented version for the true version and a separate else there. So let's now go over to Python and look at that. Here's the second file. And I'm going to give it an arbitrary value to x up here. I'm going to set it to 6. And then I want to see what happens if I evaluate this. Well, I can look at the code structure to try and get a sense of that. That first if, I'm going to evaluate that expression and get a Boolean value back. If it's true, I'm going to go in and, I'm going to evaluate that next if. And depending on whether that's true, I'm either going to pick up that piece of code or pick up that piece of code. And you can see the structure here. If the remainder of x divided by 2 is 0 and the remainder of x divided by 3 is 0, then it's divisible by 2 and 3, and I'm going to print that out. Otherwise, if it's divisible by 2, but it's not divisible by 3, then I'm going to basically print out something appropriate. However, if that first test, this test up here, is not true, then I'm going to jump down to a different special form here, called elif, which is else if. And that says, if this is not true, then let me do another if test. Otherwise, check to see if this is true. So there's another Boolean expression. And if that is true, then I'll execute this piece of code. But if it's not true, then I'm going to go, where am I going to go? Well, notice that I have no else clause here. And that's okay, because if that's not true, I'm simply going to skip to this point in the code and pick up the rest of it. Now, I could have put an else there and had that else do something, but that's a choice I have. All right, let's go back over to Python and let's load this in and see what happens. Aha. It says divisible by 2 and 3, which said back here in my code, if I use my little cursor here, it said that test was true and that test was true, therefore I printed that out. Let's look at a different version of this. Let's change x to be 5. And let's now load that in. I need to save that away, which I will do. It didn't print out anything. And why was that? Well, it's not divisible by 2, so it goes to the elif clause, but it's not divisible by 3, so it simply skips down to the next point. And one of the ways I could have fixed that is to come back over here and say, otherwise, print not divisible by 2 or 3. Okay, let's save that away. And now that's where it picks up the else clause. So you can now trace through the different ways through this code, but using nested conditionals to control different branches so that I don't just have a binary branch. I can have multiple branches through the code. Another way to do this is to use compound expressions for our Booleans. I don't need to do just a single Boolean test, but I could have 2 tests and put them together using the things I talked about earlier. So I could say, for example, if x is less than y, or y is less than z, then do something. Otherwise, do something different. So I can start putting together more complicated things. And we're going to be able to start using those to also control how we move our way through these branching programs. Okay, so where are we with all of this? Well, now that we've got conditionals, we have the ability to do different things based on that choice. And branching programs allow us to do that. Notice, however, it's still the case that at most, each statement gets executed once. If I think about each statement in my code, I don't do them multiple times. I may skip some of them depending on the test. So each statement still gets executed at most once. And as a consequence, the maximum time to run a program like this depends only on the length of the program. We see that these programs, whether the straight line programs or simple branching programs, run in what we call constant time. The amount of time it takes depends just on the length of the program. These are still very simple programs, although we can now make some decisions on them. And in the next lecture, we're going to pick up on how we actually add one more piece to start getting more interesting elements to our programs. But nonetheless, you now have the ability to start writing simple programs to do computations for you.